Welcome to this course in data science. While the title includes the word introduction, it is a rigorous, conceptually grounded course designed to provide a broad but serious foundation in data science. We assume students enter with a solid background in computer science, enabling us to engage meaningfully with the technical concepts, methods, and systems that underpin modern data-driven work. Welcome to the course. Computing isn't about producing outputs. It's about producing understanding. Data, algorithms, and models are not the goal. They are the tools. The real value of computation lies in the clarity it brings, the patterns it reveals, and the questions it helps us ask better. In a world driven by data and AI, this idea matters more than ever, because numbers alone don't create knowledge. Insight does. Specific topics covered in the course, including breadth and depth, will depend on the instructor teaching the in-person course. In general, this course is structured into 6 progressive modules, moving from foundational tools to advanced modeling. Students begin with Python, Pandas, data collection, visualization, and text processing, then build mathematical and statistical foundations, including linear algebra, PCA, and probability. The curriculum advances through statistical modeling and machine learning and culminates in deep learning, neural networks, LLMs, and recommender systems, with additional topics such as big data platforms and human factors introduced as time permits. To prepare for a career in data science, computer science majors build a strong foundation in both computation and mathematics. Core courses such as algorithms and data structures develop essential problem-solving and programming skills, while calculus and linear algebra provide the mathematical framework for data transformation and optimization. Statistics supplies the tools for analysis and inference, and machine learning introduces modern predictive and analytical methods. Together, these areas of study form the essential groundwork for success in data science. So why take this class? Data literacy and computational thinking are core competencies of the 21st century. Together, they shape how individuals understand information, make decisions, and engage with an increasingly data-driven world. How is the world changing? In traditional computer science, we design algorithms and apply them to data to produce outputs. In data science and machine learning, we provide machines with data and desired outputs, and the system learns the program itself. Students need to learn to think like computational data scientists. They work with large-scale datasets and data-intensive algorithms that operate at real-world scale. The course emphasizes not only building models from data, but also understanding how those models perform computationally. Students study the complexity, efficiency, and scalability of the systems they develop. The goal is to prepare them to design data-driven solutions that are both intelligent and computationally sound. Data science is a pipeline. It begins with raw data, collected from many different sources. That data must be processed, stored, organized, and prepared for use. Next comes cleaning, removing errors, handling missing values, and fixing inconsistencies. Then we explore the data, sampling it, visualizing it, and repeating the process to discover patterns. Finally, we build models and algorithms, choosing the right methods to represent the data and turn it into insight. We are collecting and storing data at a scale never seen before. Every day, Google alone processes more than 20 petabytes of data, including billions of search queries. By 2020, the world had generated over 44 zettabytes of data, and that number continues to grow exponentially. At the same time, we now have faster and more powerful machines. CPUs, GPUs, and TPUs allow us to process massive data sets at incredible speeds, and we've developed better learning algorithms. Deep learning, neural networks, and transformers have transformed what machines can understand and generate. All of this leads to a simple reality. Data has become one of the most powerful ways to understand the world and solve real problems. And honestly, it's hard to argue with that. In today's world, data doesn't just power technology, it creates entire careers. It begins with data collection. People design systems that capture information from sensors, software, platforms, and everyday human activity. This is where raw data enters the world. Then comes data movement and storage. Massive pipelines move that data across systems into clouds, databases, and platforms built to scale. This is the invisible infrastructure of the digital economy. Next is data transformation. Raw information is cleaned, corrected, filtered, and refined, turning noise into something usable. After that, we reach analytics and learning. Data becomes features, metrics, and signals. Models are trained, experiments are run, systems begin to learn, and at the highest level, we arrive at algorithmic intelligence. Advanced AI systems don't just process data, they generate insight, make predictions, and support real-world decisions. This isn't one job, it isn't one role. It's an entire career ecosystem built on data, computation, and intelligence, shaping the future of work. So, data science is inherently interdisciplinary, bringing together computer science, mathematics, statistics, and domain expertise. It blends technical skills with critical thinking, communication, and real-world problem-solving. Insights emerge not just from algorithms, but from understanding context, people, and systems. At its core, data science connects disciplines to turn information into meaningful knowledge. Data exploration is about understanding the past, learning what the data is telling us before we try to predict the future. It starts with two core approaches: univariate and bivariate analysis. Univariate analysis looks at one variable at a time. We summarize it with basic statistics and simple visualizations like histograms and bar charts to understand distributions and patterns. Bivariate analysis explores relationships between variables. We use comparisons, correlations, and visual tools like scatter plots and bar charts to see how variables interact. Together, these methods form the foundation of exploratory data analysis, helping us uncover structure, discover meaning, and turn raw data into insight. Data science doesn't just explain the past, it predicts the future. It does this through modeling, where we use data to build systems that learn patterns and make predictions. One major path is classification, deciding what category something belongs to. Models like decision trees, logistic regression, neural networks, and support vector machines help systems recognize patterns and make decisions. Another path is regression, where we predict continuous values, such as prices, demand, or trends, using models like linear regression, neural networks, and other learning algorithms. We also use clustering to discover hidden structure in data, grouping similar things together without predefined labels. Together, these approaches form the predictive engine of data science, turning data into models, models into insight, and insight into intelligent decisions about the future. So finally, data science isn't a one-time task. It's a continuous life cycle. It begins with data creation, where information is generated through experiments, sensors, systems, and human activity. That data then moves into data processing, where it is cleaned, organized, and prepared for use. Next comes data analysis, where patterns are explored, questions are asked, and meaning begins to emerge. But the cycle doesn't stop there. Data must be preserved, stored securely, and maintained over time. It must be made available through data access, so others can use, study, and build on it. And finally, it enters data reuse, where existing data fuels new questions, new models, and new discoveries. Then the cycle begins again. This is the data science life cycle, a living system of creation, transformation, learning, and renewal that turns information into knowledge and knowledge into progress.